Right, hello everyone, and welcome to this talk about simplifying Solaris and USD concepts. My name is Andreas, and I'm a VFX Supervisor at Swiss International in Stockholm, and we are a pretty small Swedish studio with about 30 people and another 10 or so freelancers coming and going from time to time. We mainly focus on VFX-heavy commercials, but we sometimes also do TV shows and some film and stuff like that as well. Now we are small enough to be able to kind of experiment with new things and new technologies, and we are not very locked down into departments or anything like that, like our biggest studio might be. And so a year ago we decided to make the big move to Houdini and Solaris. And so we started off doing some Solaris production with just vanilla Solaris nodes, and we tried to learn as much as we could from those productions and make our own toolsets and stuff like that. But in a sense, it's been a year of pretty much trying to make sense of it all the USD concepts and stuff like that. Right, so here's what's coming up. I want to try and simplify USD concepts for you guys and Solaris a little bit. The USD image that's out there is not always super accurate. Most of the times it's big studios kind of showing off their workflows, and they usually have a lot of custom tools and workflows that may not be very relevant to you. And so we're going to talk a little bit about some issues with USD and USD workflows in general. We're going to talk about using Solaris without having any USD knowledge, or not much anyways. And I'm going to show you our workflows and our toolsets that we are using in production. And I'm going to show you some real-world examples from projects we've done without much toolsets or pipe or anything. Right, so I think most people probably has at least a vague idea what USD is. But basically USD is a universal file format, much like Alembic is. But the difference is that USD can store much more. It can store shaders and animations and geometry and whatever you want, pretty much. But it's also a concept of how to apply different workflows. And so if you're a programmer, you'll probably feel pretty well at home with USD, because it borrows a lot of concepts from programming language concepts. Right, so most of you have probably seen some sketches, sort of like this, trying to explain different USD workflows and where everything goes and how they tie together and stuff. And at least to me, I couldn't really make sense of it in a like a real world scenario. So I'm gonna try and describe it to you and comparing it to like a more traditional workflow. So in a more traditional workflow, you would have a model, and the model goes into a rig, and the rig goes into anim. Some other things are imported, and the anim is then exported into FX and lights. I think this is probably how most people work. And of course you end up with a light scene with all the stuff in it. And so this is a very linear way, so everything goes pretty much one way. And so if you wanted to have your lights in anim and stuff, you'd have to, export that in a separate manner. And so in a USD workflow, we might have something called a shot file or a manifest file. And basically the manifest file would have placeholders for everything you want to have in your shot. So this would be just pretty much sort of like empty groups, we can call it. And then every department would load this shot manifest file in, and everyone would add whatever they wanted to add to that file and then save it back. Now in reality you wouldn't actually save the full file back. These would be what we call sublayers. So each department would have a department file, and that department file would be a sublayer within the shot manifest file. But in essence, for simplicity's sake, it's being saved back. And so everything works in this kind of cyclical way. And that means that when the light department add their lights in the scene, well, they will show up in the anim scene automatically. And same thing goes for everyone else. So everyone kind of shares and collaborate with each other in this sort of structure. And when these files are exported out or published, it wouldn't make much sense for the files to contain everything in the scene. Then you would probably end up with duplicates and triplets of pretty much everything. So what happens instead is that only the change that you actually made is being saved out. So just that little fragmented piece of data of that little move that you made, or that little change, is published. And then all of these small fragmented data pieces are combined together to form the end result. And there are massive benefits of working like this. For one, it's really cool to be able to work in a collaborative manner overall. But it's also blazing fast, right? So because everything is small fragmented data, things can move very quickly. So load times are basically zero. And if you're updating something, you're not updating a full geometry and cache. You're just updating the little change that was applied. So there are massive benefits of this. So then let me try and show you how something like this would be created using Solaris. All right, so I'm gonna switch to a more clear view here. Okay, so if I'm gonna explain this with Solaris nodes, so this manifest file. So normally this would not be probably made with nodes like this. It would probably be auto-generated from FTrack or by writing, a custom USD file. But for simplicity's sake, I'm doing it this way. And so the manifest would consist of empty placeholders. So I'm doing this here by with this primitive manifest node. And so here you can basically just write whatever you want, and whatever you want will show up as an empty placeholder. So if I wanted to add something extra here, you can just type whatever you want here and it will show up there. And so the reason for this manifest is though that everyone is using the same names, pretty much. It's a few more other reasons, but that's the main one. And so once we know what's going to go into this shot, or, then we can expect to have a certain number of imports or sublayers, right? So we know we're going to have this asset called pighead. And so we're going to request the model and look dev for that asset. And we know we're going to have a camera and anim and lights. So we're going to request to have those sublayers in there. And so right now, this is just, again, for simplicity's sake, I'm just trying to load a department file called light USD or anim USD. And none of these files exist yet. And so, again, this would, probably not be done with nodes like this, but with the help of something like an asset resolver. And then we write this thing out. Right, so once this is written out, if we look in the department scenes, they all share the same start. So they all try to load this USD that we just written out, the scene USD. And then they all have this layer break. And what that means is that anything above the layer break will be completely ignored. It won't be exported on export. And so if you didn't have that, then, all the stuff that's already in the scene would be exported again. So if we look at this top node, we can see that now we do have the exact same kind of manifest placeholders here. And so then each department starts doing what they want to do, start adding things. So if you want to add a camera, for instance, instead of it being named camera 5, which is what this $OS means, it just takes the name from the node. you want to connect it to the placeholder that already has been set in the manifest. And you would do that by just dragging in this random. So now they are linked in a way. And maybe we'll do a ground plane here. Let's say, and we are gonna connect this ground here to that. And then, another department, so maybe the modeler, is working hard on his pig head here. So he will write his USD out. So let's do that. All right, and as soon as that one is out, we start looking in our shots. So if we now go back and look at our track shots, we will see that now we actually have the pig head in there, just automatically. And it's because it's going to read whatever the latest is from that asset. And the same goes for all the other files as well. So now anim has this pig head as well. And so now if we would write out the track USD, that would also be imported automatically. Let's say that the looked up artist, he's working away on his sexy materials for this this pig. Anim is kind of animating this pig, and so maybe you wanna do some clusters or some weird things with your with your pig head. Then we can go in here and something like this. Maybe a soft transform will be the better way to go. Maybe we'll do something like that. So once we dive back out, he now has this elongated nose, and we do some animation and stuff like that. At the same time, Light is working on this model as well, kind of adding a few lights to it. And so then again, let's export some of these layers here. Can I just export all of these guys at the same time? Right, and so now they're all exported. So hopefully now, if we look at the scene, we'll now have our stuff in there. So now in lights, we have our look tab with the lights, and we do have the same thing in anim. Even if you look at where you were doing the transform and stuff, that these changes and animations won't happen again because the system is kind of smart enough to realize that it's already the same exact information that's already there. And so this is the way you this kind of cyclical manner where all the latest publishes from each department and each asset are automatically pushed to the scenes. And then you have this layer break to ensure that only the fragmented data would show up. For fun, we can just load this the anim file. So we go in and just load the anim file. Now you can see that there is nothing in here. There is you don't get any names or anything, and that's because the this file, the anim USD file, only consists of the data that's in here. So that's the fragmented piece of data that's been exported. So that's pretty much it. So in summary, you have this manifest that will set everything up, and then each department will work in their own scene, but importing the same thing and publishing to do the same thing as well. So what is the issues then? What are the kind of less talked about things when you work in this kind of USD cyclical manner? Well, the first thing is that since everything is these kind of like fragmented pieces of data, if you would load any of these sublayers on their own, you wouldn't actually see anything at all. And that's because the only way it would work is if it's combined with whatever was there before. And so that becomes a little bit of an issue if you want to export, say, a camera to Maya, for instance. Then you have to be kind of careful with how you export things. So the other thing is that USD is additive. So that means that by design, it's you're not meant to delete or change anything really. So you can hide things and you can unactivate things, but you cannot delete it or change the names. And this is by design to, make sure that no one screws up for anyone else. But it's also a bit tricky to work with because you need to plan a lot from the beginning to be sure that it works. Right, and then to deal with all of these fragmented pieces of data and all these versions and stuff, it becomes a lot more complex when it's done this way. And so there is an answer to that, which is called the asset resolver. And it's an API that can resolve versions in nested USD files and USD sublayers and stuff like that. But this is not something that has an UI or, is an out-of-the-box solution. This is something you need to, build for yourself. And so with this workflow, also a lot of studios are moving to sort of a push pipeline, meaning so normally if you there's an update to a file, you would go and update it manually. So that's called a pull pipeline. In a push pipeline, every new change would just be pushed to everyone at the same time as soon as they're published. And the logic behind this is that everyone should check the new versions anyways, so you might as well get it as soon as possible so you can see if there's any issues with it. And there's certainly a war of opinions about this stuff, but it does make a little bit sense to me, at least. Now, if you want to work this way in this kind of cyclical manner, in this with fragmented data and stuff like that, and you also work with other softwares, then to my knowledge, at least, there is no other software that support this workflow except for Solaris. So even though a lot of software will allow you to import or export USD, there's really they don't allow you to import a full stage, modify it, and export the fragmented piece of data that you want to. So right now, at least, there's not really a good way of working like this if you're working with other softwares. And so there's a lot of big studios out there playing around with Solaris as well, and USD for sure. And they usually have really big dev departments, so they have the resources to make their own importers and exporters and converters and whatnot for pretty much every software out there. And some of them have been, kind enough to make their pipelines open source, so we can get a sneak peek. But even that may be overkill for, at least smaller studios. So then the question becomes, is USD still worth it then? And I would say yes. USD is still absolutely worth it. USD is a great format still. You still get speed improvements. You can still work in a lot of great workflows. It will still look great and you still get everything out and stuff. Right, and that brings us to Solaris. And so what I want to try to do is I want to separate Solaris from USD. So even though they live in the same world, they're absolutely not the same thing. So USD is the file format and the concepts around it. But Solaris is, we can call it a USD editor. And, side effects gives us the option to break free from the USD restrictions if we want to. So you don't have to follow these very strict guidelines necessarily. And Solaris also automates everything into USD for you. So even if you're building something inside a subs network or importing something, Solaris will just automate that and make it into USD code. So even if you're if you don't know anything at all about save paths or anything like that, Solaris will handle that stuff for you as well. And then if you want to work with other softwares, that's, there's plenty of options to do that. Solaris is in no way limited to working only with USD files. You can bring in pretty much anything that Houdini in general can import. VDBs, caches, BGU caches, alembics, whatever. You can pretty much throw whatever you want at it and it will import it. And so I get the question a lot where things are supposed to go in Solaris. So what if you want to do a simulation or a groom or something? Should you do that in the subs network and then import it into Solaris stage, or where does it go? And in my opinion, at least, everything should go within the Solaris stage. So if you want to work in subs, you work in a sub crate, or you create an object network. And the big reason for this is that, not only is it cleaner, so you have everything in one place, but also if you want to test render stuff, you can do it within the stage with Solaris and Hydra. But if you import it into a regular subs network, then you can't actually render with Hydra, so you wouldn't be able to see all the glorious lights and stuff that's been set up. At least with Redshift, the shaders are not compatible completely. So in my mind, at least, the Solaris stage should be seen as the kind of the new default context to work in. Now let's imagine for a little bit if you're side effects and you're supposed to create something for big studios that may want to have a very locked down environment. They may have very big departments and don't want people to mess around with people's stuff. And then you would also need to think about small studios where everyone want to mess around with everything. So how on earth would you make a software that can cater to both these widely different markets? And so what I believe is that Side Effects has given us a fantastic playground to build the environment that we want. They have given us extremely powerful building blocks to do this. And they also made it really simple to customize and do your own things. Basically, all you need to do is connect nodes and wrap them into an HDA. And so a good example of this is the Karma node, Karma render node. So rendering in Solaris can be quite confusing when you start out. And if you look at the Karma node, it's very easy to use. But if you dive inside it, you quickly realize that it's just a collection of other Solaris nodes. And this is stuff you can do as well, regardless if you're a small studio or a freelancer or whatever. So then there are a few things that you do need to know about Solaris. And so I'm going to do a very simple demo here and try to explain. All right, so there are a few things that it's really good to know when working in Solaris. I'm going to show you a very simple cube based example to give you an idea how these things work. But mainly it's that everything is additive. You can override things and you can inherit from things. And it's very beneficial if you use prim paths. So we'll do a little cube here. Let's say we make another cube. Right, and so this cube is, let's say that this is an animation cache. So we'll do a quick animation on this one. Maybe something like that. And here we'll do something like that. Very fancy. So let's say we're going to bring in this animation, and this could be imported, if with like a reference node or sublayer. But for simplicity's sake here, I'm just going to merge it in. Right, so what we get now is 2 different cubes, and this is not at all what we wanted. So what we want is to merge these together, right? And the way to do that is that they have to have the same prim path in order to do that. And so this is why we use manifests and empty placeholders, so that everyone could use the same name for the things, and that you as a lighter in Solaris can assign the prim path to anything you like, and have the control, let's say. So now we don't have a manifest, so I'll just write one of my own. Let's say prop, and then this cube will name that prop as well. All right, so instantly now there is only one cube in here, and it has the animation. So then it's you start to wonder what is going on here. Is this cube overriding this cube, or is what's going on? So we can let's say we make a material library here, and we'll create a simple principal shader. And let's make it this some like pink or something, or maybe green is a fancier color. All right, and then in this thing we can just assign to geometry, and we'll throw a prop in here, and now we have this wonderful teal color. And as you can see, the material is actually applied to the first cube. But once we merge these together, Solaris and USD will take whatever extra information it can from anything. So the animation is basically added on to whatever was there before. So that's the kind of additive nature of Solaris. And speaking of stuff, you might notice that there is no way for you to change names or move things around in here in the scene graph. And this is by design, so people don't screw up things further down the line and stuff. There are ways to do this. In 19, they have some really good tools for this, but you can also use Stage Manager to change some of this stuff. So there you can rename this to whatever, or you can delete it completely and stuff like that. So look at that, it's gone. But this is not a procedural node, so I wouldn't really recommend using it in that way. Or I'd be very careful if you do. All right, so let's talk about overriding things. So let's say that you have this animation, but you want to override the animation. You want to pretty much remove it. So what you can do then is you can create one of these lovely X forms. And you'll set this to edit mode. And then you'll throw in again your prop. This is the one you want to affect. And everywhere in Solaris you will see this set create, set fixed block, do nothing, blah, blah, blah. And so I can pretty much set this to block, and then it will remove all the animation previously there. There are also other options. So if I, right now it's set to append, which means that if I scale this, it will just append what's already there. Or if I rotate this a little bit, it will just append to what was there. But I can also select it to completely replace. And then another way to override things is, let's say I'm not happy with this teal, and I want to change it in some ways. Then I can do edit material here. And same thing as always, I use the prim paths to show what it is I want to modify. So we throw this shader in here, and we load it. And now I have the network here. And so if I look at the network, I can go in and I can select these checkboxes of whatever I want to change. So let's just make this, now we can make this, this pink color. And so now we have overridden the animation and the material on it. And that's it for that example. All right, so let's talk about our solution. So the main idea for building our own toolsets and stuff was first based in that it has to be 100% hackable. Since we work in commercials and there's usually not a lot of shots and not a lot of assets, but it's almost every project is something you've never done before and you have very little time to do it. You need to be able to move very freely and do whatever you want. The second thing was to eliminate time wasters. So all the time being spent, opening a scene or publishing or updating things, all that stuff we try to write down and see what is it an artist does in a day, and how can we minimize each step a little bit. It also needs to be very easy to get into. So we have freelancers coming in that's never heard of Solaris. And so is there a way to get them up and running in like a couple of hours? We also needed to work with, vanilla Solaris nodes. So if our tool sets and stuff are too limited or a break or anything, then you can always, brute force it with vanilla Solaris nodes. And so we started doing a bunch of crazy experiments, but we decided that let's just keep what works and throw away what doesn't work. And so this is very much the start of our Solaris journey, and I'm sure it will look wildly different a year from now. All right, so for the Swiss nodes that we have created, we have about 10 nodes currently, and it's the usual suspects of import, export, rendering, settings, and stuff like that, and a few extra ones. And so we can start with the base node. So the base node is our starting node, and the main purpose of the base is that it brings in this manifest that we've talked about. So all the placeholders and stuff. And it gets all of this information from FTrack. And so we can add a bunch of useful information about lenses and stuff like that if we want to. And it already has a bunch of lights in it already from the start. And this is because we wanted to, we want everyone to have kind of start the same way. And so we have some settings for the floor. You can make it bigger, smaller, more shiny, you change color and stuff like that. You can have shading balls in there or not. You can, we have some turntable settings if you want to, shoot out some, assets and stuff like that. And these lights, they also have, so you can choose, different kinds of dome lights in there. So when you're starting off, you have some different dome lights to play around with, to customize your scene. And so we also have this button for creating a render template. It's easier for new artists coming in to just get a shot up and running, sort of. So first up, we have our assets nodes, and our asset nodes are HDAs, and inside them. It's basically an empty skeleton where you can, add whatever geometry or whatever you want, and you have some materials you can assign and or create rather, and you can do some tessellation settings and stuff like that. The way we handle it is that all assets is one variant. So even the first one is a variant. And this is so we can actually remove, so we can block all variants and there's no assets in there at all. And stuff like that. And if you want, another variant, you would just pretty much add your next thing here or something like that. So if you're happy with your asset, you can then publish it. Within here, you select your thing, and then you could create a new look there, for instance. But we also decided that you could load things through this menu. So for commercials, there's not a lot of shots and not a lot of assets. So we realized that it was a much faster way to use these kind of drop-down menus for imports and stuff, instead of using an import window where you need to open up and find and stuff like that. So we can load this slot guy in here, like so. And I'm just going to set this to scene scale 1. And now he is in there. So moving forward, we have some Swiss AVs and render settings here with some pre-made stuff in it. It's nothing super complicated. And the next tricky one, or different one, is our context node. So what it does basically is that you can select a shot or an asset, and it will get the frame range and other useful information. You can also clear variants, so you can remove all the assets going into the shots and just manually add the ones you want. So the main difference is that normally in USD and Solaris, contexts work upstream. So if you were to add a context option, for instance, that would affect the nodes above it. For us, we wanted to have context be inherited downwards instead. So we kind of made our own solution for that. And then in between that and the render node is where the bulk of the work would be. That would be your imports and your edits and overrides and like mixing and stuff like that. And then you would have your render node. And in the render node, we also chose a different route where one render node is one render. And the reason for that is that we, very quickly want to make multiple versions of renders. So this might be a preview render, but then you'll do another one, which is maybe a tech pass, and then you want to have some settings turned off, for instance, and stuff like that. And we also kind of like this old school Mandra style of having slots for excluding objects and mats, having mats and stuff like that. So we added that in. And so for importing and stuff like that, we have the Swiss import. And the Swiss import is pretty much the same thing. It will inherit from the context as for that shot, and now it will look for shots within or publishes from that thing, and then you just kind of select. And like always, you need to connect the print path to whatever it is you're importing. So if we are importing the cache for the slot here, then one might argue that shouldn't this just be set automatically to slot? Well, I would, I'm tempted to say yes, but the problem becomes when you want to have maybe 5 slots. So if you're importing caches and stuff, how do you know which slot is going to be connected to which if they're all looking the same, pretty much? So that's why you need to select this path yourself. So maybe this one is for the slot, but then maybe another slot cache is for a different slot, slot number 2, so that's why we set it manually. And so we would pretty much go on, and we would import our cameras and stuff like that. And there are quite a few nodes to import things in Solaris, so we chose to combine them together. So USD imports and video caches and VDBs and stuff is automatically kind of switched depending on what it is you're importing. This can also import images and replace it in the base node DOM, and it can also set the image plane for the camera if you want one. And so, like a TV chef, I have already prepared some important stuff here. So basically, all I've done extra here is that I've imported the slot cache, the fur, and the camera and the image plane for the camera. I've set my variants and messed around with some lights. So the way we do it when this is being inherited by the context is that if you want to set up the next shot now, then all you need to do is drag this out, and we'll change this to let's say shot number 40. Right, and now we can see we have that shot set up. So if we look through the camera, we can see we have everything in there. And then let's do another shot. So let's do 50, which is a close-up shot. And now we can see that shot is also set up in here. And so, of course, you would want to add some, the props or whatever you want in particular shots, and you maybe want to branch out. So similar props and stuff is branched to different to kind of different branches, if that makes sense. But you would just go on like this and just create more and more shots, and then basically all you need to do per shot is to dial it in with lights and props. And so this kind of workflow becomes very efficient in terms of working. And the idea for us having these branches of shots instead of going maybe the kind of katana route where you would just do separate out changes and stuff like that, is because it's a lot more easy to see what you're doing. And if someone else is taking over your scene, it's very easy to just isolate, like, oh, this is a shot. And so another thing we wanted to do was to try and auto name everything. People are notoriously bad about naming nodes. So we have made it so that nodes are naming themselves based on whatever content is in them, pretty much. Lastly, we have a little fancy Swiss comp node here, which is it can basically composite something that you have in your render gallery. Let's see if we have something. So you can grab one of these render gallery image that you have, and then you can comp it against some solid background. But you can also grab the image plane if if there's an image in the camera connected to this tree, it can kind of automatically grab that image as well. There's some rudimentary keying functions here that you can use. And you have some defocus options and stuff like that. It's not meant to be a nuke replacement or anything like that. It's primarily just to be able to quickly shoot out some quick dailies and stuff like that, or turntables or similar. But it can also be if you choose first input as the CG image, and this shot is rendered out, it would automatically grab the render from that, and then you can also connect the second input to a Swiss import file, and you would kind of use it A over B like in Nuke. So that's pretty much it for the Swiss nodes. And so what I've just played around with here is a project we did for Coop, which is a Norwegian convenience store where a sloth was dancing around enjoying the store. And so actually in the same file I have the full 33 shots that a single lighter did in 3 weeks. So this is one lighter working for 3 weeks. I think it was 33 shots in total. It was of course backed up by animators and groomers and stuff like that, but in Solaris it was just one person. And at this point we didn't have a lot of custom nodes, so I wanted to show you this because it's very much made with vanilla Solaris. And so here, because there was just one person working, the scene structure here was made manually with one of those primitive nodes. And so you can see everything, every placeholder is being set up here. And so some scene scales and some rudimentary stuff. And again, this these render settings and stuff is just native Solaris stuff. Got some lights going on, and here's some settings for shadow catchers and stuff like that. So the render geometry settings is a very important node overall. And then we have our assets here coming in as regular HDAs. And so at this point, these were everything was just manually imported. We had a few different variants for the fur. As you can see here, this was a fur variant only for his arm, for some close-ups when he's messing around with the phone. And we added some materials and set motion blurs and stuff like that. Then there's a bunch of settings for object IDs and stuff like that. And then similar to what I just showed you, each shot is then being overridden into one of these lines. So each one of these lines is one shot. And over here we were basing a lot of shots on another shot. So that's these structures can become wildly different and kind of grow and do whatever they want. In a sense, they don't have to be, they're not always these kind of linear lines. They can kind of grow out depending on what they have in common and stuff like that. So basically, if we look at what is going on inside, a shot. So for instance, we are changing the HDRI with our render properties here. We're loading in the cameras and layouts and stuff like that. And for and again, all of these primitive paths are set to whatever whatever name was in the kind of manifest placeholders. And then there's some overrides, overriding material here. Here's another overriding material. Some things gets moved around for the layout to be snug to the plate for shadow catching and stuff like that. Messing around with the lights and stuff like that. And it's pretty much the same story through all of these. It's just importing the stuff and then overriding what you want to override. And some of them have some props and some of them don't have props. And some of them have more changes and some of them have less. But in essence, they all follow the same kind of recipe. And so with the Swiss nodes, we've been able to speed up this workflow tremendously and kind of compact all of these shot trees a lot. And so that is pretty much what I wanted to show you. And so that's pretty much how you could work with Solaris in kind of vanilla mode. And in here, we don't really consider anything about USD workflows. All right, so the two key takeaways here is, of course, don't worry too much about USD. The workflows out there, most likely they're not very realistic to use just yet. I'm sure they will be in the future, and I'm looking forward to it. But right now, it may not be so relevant for you if you're a smaller studio. And the second thing is to start seeing Solaris as a playground and customize it, the way your dream environment should be. There are no rules that you have to stick by. There's no USD police that's gonna chase you around. So just go wild and do whatever makes you happy and and helps you out in your day to day. So that's the two key takeaways. And Houdini 19, it has massive improvements with KineFX and Karma and Material X. And we are at Swiss, we're running tests now to see if we can completely move our rigging and animation into Houdini. And we are extremely tempted to switch over to Karma as well. I think that the release is pretty big this year for Solaris. And so I'm going to leave the big features to someone else, but I'm going to name a few golden nuggets that warms my heart, at least. So one is this asset reference node, which is new. And it's pretty much the same as a regular reference, except that now you can actually select variants within it. So you could load a USD and set the variants at the same time, which is very sweet to be able to do. The render cameras now have official support for background and foreground images, which is amazing. So now we can kind of throw our Python hacks that we did in the trash. Another lovely node is the restructure scene graph. So normally you can't really change much in Solaris. So if you want to change stuff in Solaris, you're a little bit out of luck usually, because in the scene graph you can't. It's read only pretty much. You can't rename it or move or delete anything. You can do that with the restructure scene graph. So you can reparent things in different ways, and this is a godsend, especially when you get third vendor software stuff. And so we're using this one for creating our own variant node, actually. So variants can be pretty sensitive and a little bit scary to work with. And so in our own node, we're restructuring all the inputs that we get, so we make sure they are named correctly and in the right paths and stuff like that. Another golden nugget is the modify paths. And so this one we've started using in our import nodes. So you can pretty much change names and stuff depending on whatever comes in. And so, for instance, you can search and replace for pesky namespaces and stuff like that, which is awesome. Another thing is the resample transforms, which is also new, so a lot of people don't know, and I didn't know that Solaris only, or USD in general actually, it doesn't have to do with Solaris, only calculates time samples for motion blur once it's written out. And so if you're trying to animate something within Solaris, you would probably not see any motion blur. And so Solaris is helping out with that, with this kind of recalculating of time samples on the fly. And then you can use that with our cache node to get sweet motion blur. And there are a lot of other cool things, but I'll leave it at that for now. And with all of these, other AI tools and real-time renders, on the horizon, and USD just gaining more and more traction every day, and of course, Solaris killing it every release. I don't think has been a more exciting time to be in VFX. So it's going to be a couple of great years going forward, I think. All right, thank you everyone. My name is Andreas. If you want to reach out, it's andreas@swiss.se. And take care, everyone.